This is a short presentation to give an overview of the proof of concept supply chain network on Hyperledger Fabric. I will run through these slides quickly, just going over some of the high points, but feel free to pause and read the slides for more detail. There are two layers when setting up the Hyperledger Fabric. The first layer in the fabric is the network, which involves setting up the nodes and connecting them with channels. The notable point here is that instead of using third-party frameworks provided by Amazon, Microsoft, or IBM, I have chosen to develop the network from scratch using just the Hyperledger Fabric binaries. This gives us maximum flexibility in configuring the network and removes any potential barriers to entry. The second layer in the fabric is the business network application. This is the business logic in the form of smart contracts or so-called chain code that run on the channels. The first point I would highlight on this slide is the fact that this network supports dynamic onboarding. Most online examples of Hyperledger Fabric bootstrap a network with pre-configured organizations. This makes the network installation easy, but it does not support the real-world requirement for organizations to be added dynamically to an existing running network. The second point on this slide is that once configured, all organizations will be on a level playing field. There are no privileged organizations, and the network is completely democratic. Now let's discuss the details of the Certificate Authority Service Node, or the Member Service Provider. Hyperledger Fabric provides two binaries to support the CA server. Fabric CA Server runs the server that manages identities and issues certificates. Fabric CA Client is a utility that interacts with the server. A typical scenario is as follows. A registrar or admin will register a new user with Fabric CA Client by invoking the register command and providing a user ID and password. That information is also passed directly to the user. The user then invokes the enroll command on Fabric CA Client with the user ID and password provided, and if successful, the certificate and private key are installed on the host. These materials are then used to interact with the Hyperledger network. There are many identities required to set up a network. Admins are required for each org, including the orderer. Every peer requires an admin, and then an admin is needed for the channel on the peer, and another network admin manages the chain code installed on the channel. Let's move on to discuss the orderer service node. The orderer is mainly responsible for maintaining the ledger or blockchain, and in particular, the order of the transactions on the ledger. It maintains a list of organizations and controls peer access to the channels based on channel configuration. Two binaries are required on the orderer node. Config.txgen is a utility that takes a YAML config file describing the channels, and it outputs the channel artifacts needed to set up the channels, namely a Genesis block and a channel creation transaction. The Genesis block, or the first block in the ledger, contains the channel configuration. The channel creation transaction is invoked by a peer node to actually create the channel. One point of interest on this slide is that the configuration of the orderer includes an orderer type. The orderer binary includes the solo messaging mechanism as a built-in orderer type. This is useful for development, but as it only runs on a single instance, it represents a single point of failure in the network. Other options for this type include Kafka and Raft, which need to be explored for a production-ready network. The second binary is orderer. This binary is basically just used to launch the orderer node. A typical scenario is as follows. The orderer admin updates the config.tx.yaml file to define the network and submits it to the config.txgen utility. The outputs of this are the Genesis block and the channel creation transactions. Next, the orderer, which is an identity created by the orderer admin, updates the orderer YAML file with the runtime parameters, including the location of the Genesis block, and uses this to launch the orderer. Later, a peer will create the channel by fetching the channel creation transaction and submitting it to the orderer. Which brings us to the final node type, the peer. Peer nodes are what organizations use to participate in the network. They interact with the orderer to maintain a local copy of the ledger and to submit transactions. There is one binary needed for this node type. Peer is the binary used to launch the peer node. It is also used as a utility to manage the channel and chain code. Recall that the orderer scenario required a peer to complete the channel creation. Let's look how this is done by following the sequence of events for launching our first peer. For starters, the peer will need the channel creation transaction file that was produced on the orderer. In our setup, we will use S3 as a share file store in order to transfer files between Fabric nodes. In the future, these files should be transferred in a more direct and secure manner. For now, our peer can get the transaction file from S3. The peer calls the orderer with the transaction file to create the channel. That command returns the channel's genesis block. The peer calls the orderer with the genesis block to join the channel. Once the peer is joined, it still has no rights to do anything on the channel because the channel configuration, stored in the genesis block, doesn't know about this organization. To remedy this, the peer fetches the latest configuration from the orderer and with some magic modifies the file to include the new organization details, its peer node, etc. It signs this updated config and submits it back to the orderer to update the channel. Since this is the only org joined to the channel so far, there are no other peers to vote no, so the channel is updated. Subsequent peers will need the genesis block and channel configuration in order to onboard themselves, but they will not have permission to get these files from the orderer. Instead, they will come from the peer that we just joined. This new peer fetches the latest channel config and genesis block from the orderer and puts these artifacts on S3 for the next peer to use. Now let's join a second peer. This peer will get the genesis block from S3, as it cannot get it directly from the orderer. The peer calls the orderer with the genesis block to join the channel. Once again, the peer is joined to the channel, but it is not yet in the channel's configuration. The peer gets the latest configuration from S3, modifies it as before, signs it, and attempts to update the channel. At this point, the update will fail because there are one or more existing peers that need to vote on the update. To provide for this, the update channel configuration is uploaded to S3. From there, other existing peers can download that configuration, sign it, and attempt to update the channel. Depending on how many peers there are, this process will be repeated until enough votes have been registered to update the channel. Once the channel is updated, the new peer can again fetch the latest config and genesis block and upload them to S3 for the next peer to use. That concludes the discussion about the network layer. Now let's move on to the business application layer. We use Hyperledger Composer to describe the business logic for our channel. Composer provides a nice high-level abstraction of the various participants, assets, etc. We won't discuss the Composer code in detail, but rather how it is installed and instantiated on the network. For starters, we use the Composer archive create command to bundle the chain code into an archive file. We will have two archive files, one for the supply chain channel and one for the private channel. Installing the chain code on the first peer node involves creating an admin with the channel administrator role. This admin then installs and subsequently starts the chain code. The start command automatically creates a network administrator, which can then be imported and used to connect to the running network. Installing the chain code on subsequent peer nodes also starts with creating the channel admin and using it to install the chain code. Since the network is already started, this command is omitted. It was the start command that created the network administrator for the initial peer. node. So for subsequent nodes, there's a different process for creating this administrator. This process involves the cooperation of an existing administrator from another organization who will sponsor the new network admin. Once this is done, the new network admin can be imported and used to connect to the running network. That concludes the overview of Hyperledger Fabric. Now let's put this into action by setting up an end-to-end demo. We will create a new network that is bootstrapped with only a CA server and an orderer node. The orderer will specify two channels, supply chain and private. The private channel will be used to share information between two organizations that other organizations should not be able to access. We will add 4 organizations to this initial network and will create user identities for these organizations. Here is a graph of the network we will set up. The dashed box on the left contains 2 components that define our initial network. The 4 organizations, each with a peer node and a user, are added to the network one at a time. All 4 organizations are joined to the supply chain channel, but only the importer and exporter organizations are joined to the private channel. The way we will do this installation is as follows. First, we will create a setup host that will stage our network configuration and installation. This host will download the Hyperledger Fabric binaries and create installation packages for 3 types of nodes, the server, the orderer, and the peer. It will also create the business network archives for the supply chain and private channel chain code. This setup node will ultimately upload 5 files to S3, 3 installation packages, and 2 business network archives. To install the CA server node, we download the server installation package created by the setup host. We initialize and start the server and register the orderer admin. Every new org admin that is created will need the certifications from the server and the server admin, so these 2 PEM files are uploaded to S3. To install the orderer node, we download the orderer installation package created by the setup host. We also download the PEM files from the server. The orderer admin and orderer identities are set up. The config.txtgen tool is used to create the channel genesis block and the channel creation transactions. And these channel artifacts are uploaded to S3. To install a peer node, we download the peer installation package created by the setup host. We also download the PEM files from the server and the channel artifact files from the orderer. Finally, we download the 2 business network archives that were also published by the setup host. We start by asking the CA server to register a new org and org admin. We enroll this admin and use it to create admins to manage the channels. If this is the first peer, we will create the channel by submitting the create channel transaction. Next, we start the peer and join the channel. Continuing on with the chain code, first we install the chain code, and if this is the first peer node, we start the chain code as well. A business network administrator is created and used to connect to the network. Then we create some sample participants, launch a REST server, and fire up an event listener. Installing a peer node involves collaboration with other nodes in the network. To facilitate this, the peer installation will upload a variety of files to S3. If all that sounded pretty complicated, it was. To mitigate this complexity, I've created some scripts to streamline the installation. There is a script for each host in the network that sets up some environment variables and creates an install.sh script on each host. Logging into the host and invoking the install script is all that is required to get things rolling. Installation of peer nodes requires some user interaction to handle the collaboration requirements. This process is simplified by scripts, which pause and provide cut and paste commands to invoke in other terminals.